In section 15.5, we provide an example for the object grabber action client. This client is the one that contains the logic to execute desired behaviors in the robot. So, as we've been talking about the whole class, the client is to focus on the high-level task. In our file example grabber action client.cpp, we'll have some requirements just to get started. Number one, we need object classification or ID, and also the pose, which are seen right here and right here. Ideally, these come from a vision system, but in this case, they are hard-coded. Let's take a look. So here in our main file, we basically start by calling a function called setExampleObjectFrames. And this is the function that's going to provide the pose for us to pick up the object, and also the pose to drop off the object. Okay, so this is where we hard code those poses, but this is where actually the vision system should come in to provide that information. Another thing that we need is here the drop-off location. This may come from vision or some task knowledge. And lastly, the gripper ID. So because this is a high-level node, we don't want to have any low-level details, but the gripper ID is going to be available to us through the ROS parameter server. How? Well, we're going to have a robot-specific node that is started in a launch file where the gripper ID is revealed in the parameter server. So let's take a look here. Here in the set Baxter gripper param, we see that we set the gripper ID for Baxter as the Rethink Electric Gripper right hand, and then we use the node handle to call the ROS set param and use this param name and this param value to provide that to the ROS parameter server. Okay, so these are the three things that are required by our node to provide down to the action server. Well, actually, the gripper ID is known, and then we're going to provide a grasp type, but it's required information. How does the client work? When we're in main, we get this pickup and drop off frames into these variables. Then we create the action client along with a global alias. Sorry, this is not it. We were here. So here is the action client, and it's of type object grabber, and we use this action topic. And so the object grabber AC, here we take its address and set it to the global object grabber such that we can use it in other methods outside of main. And once we do that, we're going to try to connect to the server. And if we can connect, we're going to have these three executive functions: moving to wait pose, grabbing the object, and then dropping off the object. So that's what we can see here. And for each of these methods, what we're going to do inside, is create the object grabber goal as the client, and we're going to set it up with a specific action code. So for example, here we move to the waiting pose, here we would grasp, here we would drop off the object, and then fill in other relevant information, and finally call or send the action client goal. So here, when we do move to waiting pose, we create this client message, goal message. Then we access the action code version of that, and this is defined from a header file. And then we can just simply send the goal with the message and the callback. This will then tell the robot to go to the waiting pose. For grabbing, we're going to do a little bit more. We have the action code, ID, the pose, and the default grasp option before we send the goal. And for drop off, we're also going to get a pose. This is from the drop off pose, and then also use the same default grasp strategy before sending the goal. So you can see that all of this is very high level. Now to actually run the demo, we want to start Baxter. Remember to set the correct Baxter environment for all your terminals. Then we're gonna introduce a table and a toy block into our world. We're gonna start a number of object grabber related nodes, and finally the client. So to do that, I'm gonna start like this. First thing we do, start Baxter. Second thing we do will be to, let's see, add the table and the block using the example models package. Now if this happens for any reason where the block falls to the ground instead of being on the table, we can run example gazebo set state and call reset block state. That returns the block here, and don't worry, this is part of our slide. I'll show you in a second that command. The third thing we want to do is start all the object grabber nodes. So we're going to do a launch file for that. And what this is going to do is call the node to set the Baxter gripper, set the static transforms so we can have the system reference frame and the gripper frame, start the action servers for the trajectory and for the object grabber, and set all the services for generic gripper, object manipulation query service, and a play file to move our robot to the waiting pose. Okay, and then of course making it run there. So let's try that here. Let's see if I have it. No. This is grabber nodes right here. So this is coming from the package Baxter launch files. And this will open many nodes and processes, including RViz, where we can see the gripper frame and also the wrist frame, which are going to be very useful to understand all of our poses. Okay. And finally, we would run the action client. So here, let's focus in on the robot. like so. Let's go back to our terminal. And then in this top window, we're going to have the action client like this. So this is from the object grabber package, and this is our high-level client that has no specific information about Baxter. It's just going to say move to the waiting position, grasp, and then move to the drop-off position. Just those three things. So as soon as I run this, it's sending a command to move. This is all part of the grasp, the approach pose, the gripper pose, the closing of the hand, and then the drop-off pose. Okay, so that's exactly what happened, and it's the implementation of all the code that we saw earlier. Okay, if you want to reset the world at any time, you run this command, which I showed you now, and this was initially introduced in section 3.4. So I included these pictures for you to see. So in this way you can look at the commands. So here we're moving to the waiting pose. So this is the client and here's the server. You can see success for planning, how much time it took to compute the move, and then executing. And then some other statistics. So that started to do, and now it's going to do a grab, which has its 3 steps of approach, grasping, and releasing. So here we get some other information about poses and joint angles. We get close to grasping the object, and here we're going to say, let's see, we're going to say close the hand in a second, closing right gripper right here. This is still all part of the grab action. Then we go up. So here we're moving up to the release position. We rotate that gripper, and here I don't show it in RViz, but you could see how those frames are changing based on the drop-off position. And then come back down, open the gripper, and then release. And so this is sending the goal to drop off, and we complete that execution. So that's the implementation, and it wraps up everything that we did in this section by combining the action server clients and our services to achieve a high level task definition for the client without any low level robotics. So I hope this was an interesting section for you.